Okay, well, hello. Today I'm gonna present a research paper called Robot Programming by Demonstration with a Monocular RGB Camera. This work explores a new way to teach robots using only a single RGB camera. The, the traditionally robots are programmed with a teach pendant. This method, it's time-consuming and not intuitive and usually requires an expert. Programming by demonstration, or PBD, is different. Robots learn by observing humans. The problem is that most of PBD methods need expensive sensors or multiple cameras. This paper proposes a low-cost and simple alternative. The idea is to use only one RGB camera. The system tracks the six-dimensional pose of both hands and objects. That means that the position and orientation. And a deep learning algorithm detects the key points in the image, and then a PNP algorithm reconstructs the 3D pose. In this way, a robot programs can be generated from just one demonstration. So let's start with the objects. Estimating the pose of an object from a single 2D image is very difficult because there's no depth information. The researchers train a convolutional neural network to detect the corners of the 3D bounding box of the object, as we can see in here. And then the PNP algorithm is applied to calculate the object full in 6 dimensions. This allows the robot to understand where the object is located and how it's orientated. Then the hand pose tracking. Now the human hand is more complex because it is not rigid and every person has a different size. So the researchers modeled the hand as 19 bones connected by 16 joints. So they also used ArcYuko makers to calibrate the hand size. With this information, a depth learning model detects 66 key points on the hand. Finally, this makes it possible for the robot to understand the human gesture and movements. So from hand to hand to the robot program generation, once we know the pose of the hand and the object, we can generate the robot action. A special hand gesture using the thumb and the index finger is interpreted as the robot gripper. The system calculates the grasp position and the orientations and trajectories are generated by copying the hand movement. Primitive actions like pick, move, and place are detected based on the speed of the hand. In this way, a full robot program is created automatically. Then we have the experiment that were performed with a Fanuc LR Mate 280 robot and a simple webcam. Some several tasks were tested. First, grasping different objects. Second, pick and place with one or multiple objects. And third, generating collisions-free trajectories. The human demonstrator showed the task once, and the robot was able to reply. The results were very positive, so the grasp success rate was around 90-70%. The teaching process was much faster. For example, picking boxes took more than 500 seconds with a teach pendant, but only 57 seconds within this method. The cost is very low, only $50 webcam compared to the sensor that costs thousands of dollars. This shows that the system is efficient, accurate, and affordable. The conclusions and some discussion or limitation that we have is there are some important advantages that this method is simple, intuitive, faster, and low cost. However, there are also limitators because only one camera is used. The field of view is restricted and also the accuracy is not high enough for the tasks like welding, which needs precise points and even with these limitations, the approach is very promising for many industrial applications. So in conclusion, this paper presents a new network framework for the robot programming. By demonstrating using a single RGB camera, this successfully learns the object and hands poses, generates grasps and trajectories, and creates a robot program for and after just one human demonstration. In the future, maybe this system could be expanded within multiple cameras and improve accuracy. Overall, it represents low cost and efficiency alternative for teaching robots in industry. So thank you so much for your attention.